Hello everyone, welcome to my channel Nerdy Coder. If you're the first time seeing my video, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. In this video, I will show you how to use a contra-first approach to design RESTful APIs with OpenAPI. I will also show you tools you can use to generate server and client code automatically from an OpenAPI document. Contra-first approach is a methodology of developing a specification before you begin implementing your service. This way, you can define the structure, behavior, and expectations of your API in a clear and consistent way and share it with your consumers and collaborators. There are many benefits of this approach. It helps you to focus on the features and functionality of your API rather than the implementation details. It enables you to better collaborate with other developers and teams who use or depend on your API. With an API contract, both the front-end and back-end can be developed in parallel, without having one depends on the other. Using a contract-first approach also allows you to generate code, documentation, and clients for API automatically, using tools like OpenAPI Generator or Swagger CodeGen. This is going to save you a lot of time. Before we begin, I want to quickly show you how we could generate code from OpenAPI document. I use Swagger Editor to create an OpenAPI document for a calculator API. It is a YAML file with about 200 lines. On the right-hand side is a Swagger UI showing all endpoints in this calculator API. It has a health check endpoint, as well as 5 calculator endpoints. You can quickly generate server stubs and client SDKs for your API. To generate server stub, you can select Generate Server from the menu, and then select your server framework. I'm going to choose Node.js Server. To generate client SDKs, you can select Generate Client, and then select the programming language or client libraries. I'm going to choose TypeScript SEO. The options here use Swagger CodeGen to generate your code, but you can also use OpenAPI Generator to generate code from OpenAPI document. OpenAPI Generator is a fork of Swagger CodeGen. It supports additional programming languages and frameworks, and is community-driven. I'm going to put the links of Swagger CodeGen and OpenAPI Generator in the description below. Here's the generated code for the Node.js server. The code sets up a HTTP server. It includes code for calculator and health controllers. The controllers reference the calculator and health services. These are function stubs which you can modify to implement your own business logic. These function stubs cover all endpoints defined in your OpenAPI document. Here is the generated client code for TypeScript SEO. It includes TypeScript types for all the objects defined in the OpenAPI document. It also includes the client code to call the calculator API, including the calculator endpoints and the health check endpoint. They are ready to be used in your application. So how to create API contract with OpenAPI? OpenAPI is a standard and language agnostic format for describing RESTful APIs. You can write an OpenAPI document in YAML or JSON using a set of keywords and syntax rules. This means that you can create OpenAPI with any text editor. In this video, I'm going to use Swagger Editor to create an OpenAPI document for our calculator API. You can access Swagger Editor at editor.swagger.io. The latest version of OpenAPI Specification is 3.1. However, most OpenAPI tools currently support up to version 3.0. Therefore, my discussion today is going to focus on version 3.0. I'm going to clear the editor, and then I will explain the basics of OpenAPI. An OpenAPI document consists of several sections, such as the OpenAPI version, the info section with metadata about your API, the service section with the base URLs and server connectivity information of your API, the paths section with available paths and operations for the API, the components section with reusable definitions of schemas, parameters, and responses, etc. The security section containing the security requirement of your API, the tag section with a list of tags used by your API, which can be used to organize your APIs, the external docs session with links to external documentation. Out of these sessions, only the OpenAPI info and path sessions are required for a valid OpenAPI 3.0 document. Nice things about creating an OpenAPI document with Swagger Editor is that it will validate and show you errors in your OpenAPI document, as you can see them on the right-hand side. The OpenAPI version is a string of the OpenAPI specification version you are using. I'm going to use a version of 3.0.3, which is the latest OpenAPI 3.0 version. The info session is an info object. This info object requires at least two fields. The title field, which is the title of your API. In the case of our calculator API, this would just be calculator API. The version field, this is the version of your OpenAPI document. This version is defined by you and is not the version of the OpenAPI specification. I will give a version of 1.0.0. You can also add a description and URL for terms of service, contact information, and license information in this info session. I will skip them in this example. The server session is an array of server objects. A server object contains at least an URL field for the target host. The URL could be a full URL or a relative URL. It also supports server variables. If you don't provide a server object, your server is default to be the same host where your OpenAPI document is served, which has a relative path of a /. You can optionally provide a description for your server and define variables in your URL if your URL uses server variables. I will skip over the path, components, and security sessions and talk about them last. The tag session is an array of tag objects. A tag object contains the name of the tag, which is a required field. You can optionally give it a description and link to external documentation. In this example, I will have a health tag and I'll give a description of health check. I will also have a calculator tag. I will give a description of calculator operations. The external docs session is an external documentation object. This object is optional. But if you do provide one, you have to at least give it a URL field and optionally a description field. I'm going to put my YouTube channel as a URL and give a description. Now, back to the path and components sessions. You will spend most of your time on these two sessions when creating OpenAPI documents. The path session takes a path object, which contains the available path and operations for the API. It contains a relative path to an individual endpoint. The field name must begin with a /. We will first create a health check endpoint, which has a path of /health. Each path takes a path item object. A path item object contains the HTTP methods. In our case, it will be a HTTP GET method. This GET method takes an operation object. An operation object contains multiple fields. I'm going to go through the common fields which we are using. It contains an optional description. It could also contain an optional operation ID. Operation ID is a unique string used to identify the operation. The ID must be unique among all operations described in the API. When Swagger CodeGen generates the client code from the OpenAPI document, it uses this operation ID to define the function name of the API call. Therefore, it's recommended to follow common programming naming conventions when setting this field. I will also tag this operation with the health tag. This health tag is the one we define in the tags session. It should also contain a responses field. This is the only required field in the operation object. It takes a responses object. A responses object could have a default response or response by HTTP status code. In our case, it will return status code 200 if health check is OK. Each status code takes a response object or a reference object. I will provide a response object here. It contains a description, which is the only required field. You can also provide a response content. The content is a mapping between the response format and a media type object. In our case, the response is in JSON format. The media type object contains a schema field, which defines how the response content looks like. There's also an example field which you could provide example response content. I'll skip it here. I like to define the schema in the components section of the OpenAPI document and reference that schema here. You can define reusable objects for different types of objects. In our case, I will define a schema object in the field schemas. It contains a mapping of the name of the schema and the schema object itself. I will name it health status. A schema object is an extended subset of the JSON schema specification. JSON schema is another specification. It is a declarative language that allows you to annotate and validate JSON documents. In our health status schema, I will give a description. I will define the type, which is an object. Besides object, a type could also be string, number, integer, boolean, and array. This object will have multiple properties, which are defined by me. I will define it to have two fields, a status field and a timestamp field. The status field has a type of string. This string is an enum and the only option is OK. The timestamp field is an integer. This is the number of milliseconds since epoch time. I will also give an example. By default, all properties defined in the object are optional unless you specify otherwise. To define the fields as required, you will include the field required in the object here, and then list all the required fields. In this case, both the status and timestamp fields are required. Now you have defined your health status schema object. To use it in your API operations, you can use a reference object with a field of $ref and a value of hashtag /components/schemas/health status. Hashtag refers to this document, and components refers to the components session. This health check endpoint could also respond with a status code of 500 in case there's any server-side error. You can define another response in the responses object. Since this 500 response will be used across multiple paths, I will define this response in the component session and reference here as well. I will first define a schema for the error response. And then I will define the response for internal server error. This is also a JSON response and it references the error model. Now I will go back to the health checks responses object and reference the internal server error response. The health check endpoint is now completed. You can check out in the Swagger UI on the right-hand side to make sure everything is correct. Now, let's move on to the calculator endpoints. Once you get the basics, the remaining could be quite repetitive. I will first create the schemas I need for the calculator endpoint. I will have a calculator command schema to create a calculation. And a calculator result schema to represent a calculation result. As you can see, the operator, operand 1 and operand 2 fields in the calculator result overlap with the fields in calculator command. One way to eliminate the repetition is to create a calculator result schema on top of the calculator command schema. To do it, you can use the all-off field like so. The first calculator operation we need is to get all calculations. It will return an array of calculator results and potentially return a 500 error. We will then add an endpoint to create a calculation. This endpoint has the same path as the endpoint to get all calculations. So I can add a post method under the path /calculator. This post request requires a request body of calculator command and returns a calculated result. Since this request body could be shared between this create calculation endpoint and update calculation endpoint, I will create a request body in the component session and reference it here. We add a field named request bodies in the components session. A request body object is quite similar to a response object. It has a field name required to indicate whether this request body is required. I will then reference this request body in the post request. There are 3 more endpoints we need to add: get a calculation by ID, delete a calculation by ID, and update a calculation by ID. These 3 endpoints share the same path, but with different HTTP methods. We can use templated path to indicate that this ID is a dynamic path variable. In the path item object, we can use a field named parameters to specify the required path parameters. Again, I will define the parameters in the components session. A parameter object takes a name field. The value is ID here, which is the same name I defined in the templated path. It requires an in field. In this case, the value is path, since this is a path parameter, but it could also be query, header, or cookie. You can optionally provide a description, and you need to indicate whether it is required. If you're using it for the path parameter, this value must be true. And then define the schema. In this case, it will be a string. One thing which is very useful in the schema is that if the type is string, you could optionally provide a record expression to restrict how the string should look like. If I want the string to contain only digits and letters of A to F, I can do it like this. I will add an example as well. Now I'll go back and reference this parameter in the path. I'll first add the endpoint to get calculation by ID. I'll copy the definition from another endpoint and modify it here. In the response, this endpoint could potentially return a 404 error if the ID does not exist. I will add a 404 not found error as a possible response. I will define this not found error response in the components session and reference it here. I will then add a delete endpoint to delete a calculation by ID. This endpoint will have a response status code of 204 and does not have any response content. Lastly, I will add a put method to update a calculation by ID. For the security session, before we define the security requirement of this API, we need to first define the security schemes under the components session. Under the security schemes field of the components session, we first give a name of your choice for the security scheme. OpenAPI supports HTTP authentication, an API key, OAuth2's common flows, and OpenAPI Connect Discovery. I'm going to define a security scheme using HTTP basic authentication. This means using a username and password in the authorization header of the HTTP request. And then I can reference this basic auth scheme in the security session. If you set it like this, it means any API endpoints defined in this OpenAPI document will require this HTTP authentication. If you want to make this authentication optional for all endpoints, you can add an empty object in the security session like this. Also, if you want to use different security requirements for certain endpoints, you can override the security requirement in those endpoints. If you see an error like this on the Swagger UI, you can refresh the page and then the error should go away. This completes our OpenAPI document for the Calculator API. You can check out the Swagger UI on the right-hand side. If you want to generate code for your server and client, you can choose the options under Generate Server and Generate Client here. Or you could save your OpenAPI document and use other tools such as OpenAPI Generator to generate code for your application. This video only touches on a very small subset of the OpenAPI specification. I will include some useful links to the OpenAPI specification in the description below so that you can continue learning and understand more options to document your API. I will also save the final OpenAPI document in my GitHub site and include a link in the description below as well. This is the video I wanted to share with you today. If you like this video and find this video helpful, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. Thank you for your support. Goodbye and see you in the next video.